All right, so on this episode of MathMeowTics, we're going to start introducing you to the idea of quadratics. And first off, we're going to introduce you to adding and subtracting polynomials. Now, our vocabulary is very important in terms of talking about polynomials. A binomial, if we look at our definition here, up at the top, a binomial is a polynomial with two terms. A polynomial is a monomial, or a sum of monomials. We're going to talk about that in just a second. That's the value of x, or some term that we have. All right. Now, the degree of a monomial is the sum of the exponents of the variables in a non-zero monomial. I don't think I'm even saying that right. It's hard to say. The degree of a polynomial is the highest degree of the monomials that make up a polynomial. And we're going to talk about that in a second. Let's look at some actual pictures here so that we're not just talking about definitions, so that we can see that. The naming the polynomials, so you can name it based on the degree or the number of monomials it contains. So here, let's look. So polynomial, we have 6, all right? It's a 0 degree, all right? That means that we don't have an exponent. And we name this term, we usually say that this is a constant, all right? And the number of terms we have here for the polynomial is 1. We only have one term. Now, we name this using a number of terms, so that's monomial. So we only have one mono, meaning 1, all right? Now, the next one, we have 5x plus 6. The degree is 1. If we look at the x here, that is to the power of 1, all right? And we name that degree by looking at the whatever the term is with the x. And we also know that this is a linear. If we think about it in terms of we have y is equal to mx plus b, that's a linear equation. That's the slope-intercept form. We know that that's going to be linear. We call that a linear equation or a linear polynomial. And the number of terms we have here is 2. We could have more, but right now we only have 2 terms. And we call this a binomial. We have 2 terms. Now, the next one's where we start getting a little complicated. We have 4x squared plus 7x plus 3 plus 3. The degree of the polynomial, we look at the highest degree. So the highest degree here is 2. All right? We have that degrees right there, right above that 2. We know that that is the, we know that that 2 that's with the x there, that's the highest degree. The degree with the other x is 1, okay? So that won't be our highest degree. All right, so, and this is a quadratic, all right? We call this a quadratic. The number of terms in this quadratic polynomial is 3. And we call this a trinomial because we have 3. Our terms of our number of terms is 3, so we're naming it and using the number of terms. So this is called a trinomial. Now, the next one, which we won't spend too much time in algebra, the next term is going to be cubic, okay? We really won't see a lot of this in terms of Algebra 1. We'll loosely touch on it, and that's okay. It's not one of the teaks for the star, all right? But we need to see it so that you can recognize it in the future. It's a 2x plus 3. The degree is 3, and we call this a cubic because it's to the cube power. Now, the number of terms here is 1, so we call it a monomial. Look here. So this here, in terms of that, was monomial. So let's say, for example, I had 2x cubed plus, let's say, x squared plus, let's say, 1. That would be a trinomial, okay? But because I only have one term in this expression, it's called a monomial. Now, the last one that we're going to talk about in terms of Algebra 1, we're going to talk about, we have 8x to the 4th power minus 2x to the 3rd power plus 3x. The degree, again, we're going to look at the exponent with the x. Here the x is 1, here the power is 3, and then the highest power is 4. All right, so that power is 4. That degree is 4. It's the fourth degree. We call that the fourth degree. That's how we name that. And the number of terms in this is 3, so we call that a trinomial. All right. And now we're going to move on to some actual problems. So here we're going to talk about finding the degree of a monomial. Well, we look at what the degree of each monomial. So the first one, the degree is 1. So we're going to call that 5x. We can say 5x. That's x, 5x to the power 1. So the exponent is 1. Now here, all right, I'm going to call this, whoops, sorry about that. On the next one, again, I want to comment why the degree of a non-zero constant is 0. You can rewrite a non-zero constant such as cx to the power of 0. So the exponent is 0. So that's why we call that degree of being a 0. All right. So don't get confused, because we know if we have anything to the power of 0, so if we look at 4 and we call that to the power of 4, a power of 0, that would give us 1. So don't get confused. When we say that this is known as a degree of 0, that's because we're looking at the x value that's next to that. And if I say 4 times x to the power of 0, that would be the same thing as saying 4 times 1, which would give us 4. So the degree of c is 0. Okay, that makes sense. So let me write that down. So the 4 is equal to 4x to the power of 0. So the exponent is going to be 0, so it's a constant. Now, for B gets a little tricky to understand. I understand that we can't add if our bases are not the same in exponent rules. So we have x to the third power, y to the third power. Okay. In terms of talking about this, we would not say that we could combine those and say xy to the fifth power. But when we're talking about the degree of the polynomial, or the monomial, sorry, we would say the degree would be 5. Because in the case of this, the exponents are 3 and 2. And because that 3 and 2, their sum of those exponents is 5. So we're not saying that we can simplify this to being xy to the fifth power. We're just saying that the degree of the monomial is to the fifth power, and we're able to sum those that way. Hopefully we'll go into more detail a little bit later on. All right. I'm going to do problem number 2 and 3 in the next video. I've done quite a bit of talking in this one, so hopefully we will go from there. All right, see you then.